All right, so we left off with our cycle and showing that matter cycles, so it's a closed system. Energy flows. Energy is an open system. And what that means is we have to keep adding energy into the system and we keep losing energy. So there is energy throughout this matter system. When we talk about the matter, Um, all we're looking at is that we don't get any extra water into the system and we don't lose water out of the system. It just keeps changing form. We don't get any extra carbon or any extra oxygen. It just keeps changing form, and same with nitrogen. But with energy, we do have to keep adding energy. We do keep losing energy as well. So this is more about that second law of thermodynamics, where we need to keep adding energy in because without it, we tend towards disorder and we lose that energy as heat. So what we're dealing with right now is why energy is an open system, trophic levels, the energy pyramid, and of course, webs, and how energy travels. But as I said, energy flows through instead of cycling. And the best way to show that is through what we call an energy pyramid. All right? So the energy pyramid, or the pyramid of trophic levels, shows the levels at which energy travels through a system. So we have the sun. Sun puts energy in. So we could say that 100% of the energy that gets into an ecosystem is formed by the primary producers. And then those primary producers pass, the golden rule is the 10% rule. 10% of their energy, what we call the primary consumers, we call them herbivores. And then the things that eat those are these secondary consumers. And at that point, we would call them carnivores. Things can eat at different levels. So something that eats at both the primary consumer and the secondary consumer would be considered an omnivore because it eats both producers and consumers. But 1% of the producer's energy, or 10% of 10%, makes it there. And then we get to our tertiary, right? So that's Tertiary consumers. And they would get 0.1%. Sometimes you could get to a fourth level, but as you can see, we are running out of energy. And that's why oftentimes you don't get that many quaternary consumers. So now the energy is flowing, but what is happening to the rest of that energy? 90% of it seems to be lost. Well, a lot of it gets lost as heat at every step. And heat is for all intents and purposes, a useless energy for an ecosystem. All right, so that's our tending towards disorder. That's our second law of thermodynamics. The usable energy is getting used up and being released as unusable energy. All right, doesn't get created or destroyed. First law, it just changes form into unusable energy. Now, not all of that 90% goes to heat. Some of it goes into dead material and waste, and that goes to the decomposers. And decomposers help with the nutrient cycle. They can bring nutrients, but not energy, back to the bottom pyramid. Not energy, but nutrients. All right, so you need to know those, the way that energy is going to flow through this system. Now, we can also look at this in regards to a food web or a food chain. So food chain is just a very simple way of showing a primary producer, a primary consumer, a secondary consumer, etc. For instance, I could have a plant. So I'll draw a lovely little flower here. And that could get eaten by a mouse, like my mouse, right? Which could get eaten by a snake, my snake, and that could get eaten by a hawk. Oh, this is going to be good. All right, there's my hawk. So what we have here, the arrows point in the direction of the energy flow, and this is our producer, our primary consumer, our secondary consumer, and our tertiary. But in a food web, this could get more complicated. For instance, the hawk could also directly eat the mouse, in which case it's a secondary consumer. All right, and perhaps we have something else that can eat the flower. Let's say a little bunny rabbit. It's going to look exactly like my mouse. My bunny rabbit has big ears, and maybe the hawk can also eat the bunny rabbit. And so a food web is a complex series of food chains. All right, looking at the whole picture, you've got your two laws of thermodynamics, and they're both shown here. All right, matter is not created or destroyed, energy is not created or destroyed. However, the second law shows that to keep things organized, we have to keep adding energy because we keep losing energy as the universe tends towards chaos.